tooth pain, a cleaning, or a checkup.
I called for a cleaning.
Alright, what is your full name?
My name is Khalil Elkhattab.
Thanks. Name on file, Khalil Elkhattab. Please say 10 a.m. or 2 p.m.
Maybe tomorrow at 10 a.m.
What's your phone number?
060010008922.
Thank you, Khalil. Dental cleaning on tomorrow at 10 a.m. is booked. We'll call you back. Anything else?
Handling high volume client calls in a local businesses like dental clinics or real estate agencies is expensive, prone to human error, and loses leads outside business hours. Most existing AI solutions are either overly complex to set up or local real-time solutions for multiple clients. In this video, I am introducing VocalDesk AI, a full stack real-time voice receptionist designed as a multi-tenant P2P SaaS platform. It handles full booking workflow over voice and text with zero human interventions. So let's start it and see how it does work. For example, we find this landing page and we go here and we do as this as we are just started and we enter some information. For me, I will add here my name and my agency as this P2P P2P accent. Yeah, it seems good. And we choose the industry and we choose this or this. Yeah, language, English seems good. Time seems good. Primary cars good. Book appointments it seems good. Yeah, and we generate access code for this and we copy it and we go to login and we enter it as this and we go. Here we go. We have our dashboard and we copy this link and we give it here in your window and we enter this link. You can send it to WhatsApp, to web, to anywhere, because this the client who will use it, not you. the, the client who will use it, you are use just a dashboard, because the dashboard foresee what the what the client are called you. For example, let's bot. Seems good because now we have many choices as voice, text, and bot. We call.
Tooth pain, a cleaning, or a checkup.
I called for a cleaning.
Alright, what is your full name?
My name is Khalil Elkhattab.
Thanks. Name on file, Khalil Al-Khattab. Please say 10 a.m. or 2 p.m.
Maybe tomorrow at 10 a.m.
What's your phone number?
060010008922.
Thank you, Khalil. Dental cleaning on tomorrow at 10 a.m. is booked. We'll call you back. Anything else? Recorded your dental clinic appointment for Khalil El-Khattab. Phone 067-180-7222. Preferred time, tomorrow at 10 a.m. Your details have been saved to the dashboard.
Yeah, and we go to dashboard, and here we go. We find our name, our phone, why we called, and what time we will visit the agency, and etc. Before jumping into the code, let's step back and look at the full system architecture on Exaridraw. VocalDesk AI is structured into three clean layers: a modern React 19 front-end, an Express engine acting as the orchestration backend, and a hybrid AI and data persistence layer. And for explaining that more here in shorthand, we are using React 19 plus Date 8 and React Browser 7. This is all our have relations to just front and browser app, and this is what the admin and the client is see the dashboard and the code, and we are using time with CSS4 for that view for more for be a cool SaaS, and with speech APIs and VIP API AI with is optional, and when we have offline engine, we are using IndexedDB and smart conversations. This is good. Is just a file in our project. And for backend, we are use Node.js and Express. We are using the Express for REST API for port 3001 and the SSO stream API call stream, and we are using algorithms. And we will explain all this in the for enter to a deep explaining of what is our process and our structure, it's working as this. We are using React 19 architecture, and this work for landing page and the call code the client voice as we see in the beginning of video, and admin clinics job setup and dashboard. All this is we are see it, and here we are data is flowing as this speech recognition. Use the pipeline voice. It's working as this, and for this server is data. Our data structure is our workflow is working in as this way. And in backend, we are using it as this working flow. We are in our storage and data. We are using SQL.js file. We are using SQLite in JS engine, and data is flowing as this. And we go in here API appointment booking is going to SQL.js, and the API address is to is a storage to SQL.js, and here we go. All this SQL is going here, and we are not just using one API from OpenAI. No, we are using much of that. We are going deeply into that. We are using it as this for Demont Guardrails topic filtering, and the conversation engine.js as for stage matching, and we are using prompt and the name and phone, and open AI, yeah, etc. Now let's open source hooks use voice pipeline.js file. This hook is literally the brain of our real-time client call interface. Browser don't provide a ready-to-use phone call API. You have to build it manually or just writing the microphone speech-to-text recognition backend synchronization and text-to-speech audio output. Every edge case you encounter in browser voice apps like audio feedback loops, issue, and premature speech cutting is handled right inside this hook. Let's look at the core utility import from call agency.js and the phone extraction.js. Notice those functions like is AI speech echo is like lay make echo and strip AI echo from UI turns. Those are crucial when the browser speaker plays the AI's voice. The microphone after picks that sound back up, causing the AI to talk to itself. This those helps the functions sanitize the user's transcript in real time, filtering out make issue and isolating. We also import Git local AI replay from smartconversation.js. If the backend server or OpenAI drops these hooks seamlessly, falls back to a local offline state machine running in the browser, so the caller never hears silence. And finally, utilizes like AI asked for phone and looks like a phone call candidate ensure that when a user speaks a phone number or time slot or our pipeline extract the entity cleanly before sending it to the state engine. And then now let's a look to our structure. How does it like look? It is looks like this. Let's open this file, conversation engine.js, and let's draw to harder faces. Let's draw. Yeah, it's a big file. Let's draw. Yeah, here in the now we moved into the backend heart of our conversation system, this file server conversation engine.js. In introduction, voice apps, you cannot simply rely on an constrained ChatGPT prompt to drive a business appointment booking. It will hallucinate, forget fields, or ask for the phone number before even knowing the username. Instead, we built this deterministic state machine in Git conversation stage. It dynamically evaluates the client profile and the conversation history to strictly enforce stage order as this greeting to problem, to name, to date and time, to phone, to confirmation. Looking at line 9 as these lines, let's jump into, let's take it this. Yeah, if we take a look to this lines at 1978. Yeah, let's draw 1970, and yeah, let's see this. Each stage generates exact dynamic replace tolerate to the user's progress. For instance, when transitioning to the date time stage, the engine formats the specific service issue, like for your plumbing leak. Does Tuesday or does Tuesday or Wednesday work better? While seamlessly handling multi-language localization. One of the most powerful architectural decision in this file is the stage override handler resolve name resolve name stage override. LLMs frequently struggle with the raw speech transcription when extracting names. After confusing background noise or echo for a name, this override intercepts the execution pipeline before calling OpenAI. If it detects an issue or incomplete utterance, it executes a silent style, keeping the color on the name stage safely. Once a valid name is extracted via bill name ask prefix, it smoothly advances the state to date time. Finally in this is a real use question. Ensure the killer can ask of script question like, are you open? on Saturday without breaking the booking flow. It filters out issue artifacts first, then uses pattern matching for question words like what, when, how, or explicit question mark if a real question is detected. The engine answer if it gracefully before steering the caller back to the current booking stage. Let's say, yeah, index. Let's open new this file ai.js. Yeah, and yeah, this file is yeah, this file is important, and this is yeah, this is important file. Which servers as our hybrid AI router. A common mistake engineers makes is sending every single user turn directly to OpenAI, but relying solely solely on an external LLM for structure the data collections like names, dates, and phone numbers leads to three major problems: high latency, token cost, and worse and a predictable hallucinations. Our router enforces a local first architecture, local deterministic rules run first, and OpenAI is invoked only when necessary, such as the complex general FAKs facts or confirmation stages. Uh, look at uh, look at this. Let's look at this line. John, yeah, line 2028. Before any payload goes to the cloud, the router dynamically inspects the conversation profile and the current stage. Yeah, look this from 28 to 40, 45, 45. It injects this contextual state into generate agency system prompt, ensuring that even when OpenAI is called, is operates under tight guard 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 rules tailored strictly to the agency current booking phase. In finalize AI result, notice how local stage override interrupt the pipeline. If resolve name stage override or resolve the phone stage override catches a valid input, the router short circuits the request and returns the local replay instantly. This guarantees that sensitive the, data like phone number and the names are collected with zero latency processing without waiting for an LLM HTTP round trip. Finally, let's trace stream AI response. Yeah, the response or its function. Yeah, during structured the data collections stage like greeting, problem, name, date time, and phone. If the user isn't asking an off-topic question, the system routing the request to get intelligence make more correctly. If the user asks an open-ended question like "Do you have backend?", the system seamlessly escalates the stream the response live from the OpenAI API. Let's explore this file server called session story.js with handless active real-time call state critical architectural decision. He was not written every single spoken words or transcripts update directly to the SQLite database. Writing high frequency streaming turns to disk creates an unnecessary 10 but Linux. Instead, active call sessions are maintained in high-speed server RAM using and in memory session map. Database persistency only happens when a booking is officially finalized or a call closing. Let's look at this. Let's jump in deep. Yeah, let's look at create a call session on line 46 to 60. Yeah, from here to here. When a client initiates a call, this function generates a unique session ID, sets the status to the connected, records the exact time t- times t- times ta- times stamp, and initializes the transcript array with the agency custom greeting. In the invoke set active a call, storing the station objects in memory for instant read write access. Now look at fast line 22. 322 to 43. This is our lightweight in a memory Bob sub engine. Whatever a user speaks, an AI response streams in, or the conversation stage advances, the server triggers the break cost function. It uh, it serializes the latest station by load and it writes draw all active HTTP response streams in the source. formatted the data uh, f- as this by load in from directly to every connected agency admin dashboard. Now let's examine the server prompt generated.js, the bridge between admin configuration and AI behavior. Every business using VocalDesk AI has different working hours, unique services, and distinct brand personalities personalities. The dental clinic needs a completely different tone and roll set compared to 24 hours to 7 hours on 7 hours immigrancy looks 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 Smith. This file is responsible for dynamically compiling those admin settings into a highly structured context-aware system prompt for OpenAI on third-party voice providers like VAPI. Let's look at gener- generate agency system prompt on line 49. 49. Let's down. Yeah, from 40, 49, from 49 to 79. 79. Yeah. First, the functions extract the agency's customer configuration, resolving the specific industry, domain, working hour, available booking slots, and AI tone. It then constructs a multi-section system prompt. Notice the strict formatting with the section bonds like agency profile by organizing constraints into explicit blocks including working hours, knowledge base, and the primary goal with this drastically reduce LLM in structure drift and force the model to stay strictly aligned with the agency operational boundaries. Yeah, what makes the prompt generate so different, so effective is that it doesn't just base static text. It injects live operation data. Functions like get next available slot agency evaluate a real-time calendar available and inject the exact upcoming open slot directly into the system prompt text. This means the AI suggests appointment time to a caller. It is refreshing, fresh, dynamically calculated business logic without needed extra API round trips. Yeah. For now, this file uh, The authorization and the session security layer that protects our agency dashboard endpoints. Since VocalDesk AI manages sensitive caller data, appointment, and agency configuration, securing the administrative APIs is critical. We separate authentications into two parts as source. This file source utilizes engine.js on the client side of a local session flag and the server middleware authentication.js. On the server side, the strict root protection. Let's look at required auth inside the server inside this file lines 3 on this line from 3 to 22 or 23. uh, when an admin client makes an API request to a protected dashboard route, this express middleware it intercepts it first. If uh, if extracts the access token from either a standard HTTP header or a customer exception token header if the token is missing or expired via validation. The server rejects the request with a 41 41 status and authentication. Notice this security check on the line 12. If the URL contains an agency code parameter, the middleware ensures that the session token bounds agency matches the request agency code. If an admin tries to access another agency private dashboard or caller records, it immediately drop a 42 forbidden response. This prevents cross tenant data token. Finally, at this look at this file example. Yeah, uh, we have generate access code. Let's check out it. Generate access code. Yeah, generate access code. It's generated a clear formatted session token like this code VD83F1 100 using random hex sinuses. Those lightweight access codes allow agency admins to quickly sign in and manage their voice receptionist workspace without complex password functions. Now let's talk about algorithm uh, A. Uh, First algorithm we have is memory comparisons with exponential decay. As a phone calls gets longer, sending the entire raw conversation transcriptions to OpenAI on every turn becomes extremely expensive and introducing massive audio latency. To save this, we implemented a hybrid slides window comparisons algorithm with time decay whiting. Let's look at the mathematical functions behind the algorithms. First, we apply an exponential decay weight for formula. This, as you say it, yeah, uh, W of t equals O to the power of negative lambda times delta t with this I constant with this I constant lambda equals 0.35. What this means is that words spoken 2 seconds ago hold the 50% wide, with while words spoken 10 seconds ago decide down to near 0%. We only keep the last four terms inside our active sliding window to calculate memory footprint on the fly without heavy tokenizers. We use lightweight token estimator call of character times 0.25, assuming roughly 4 character per token. Now let's look at how we format this metric for the admin dashboard. While comparisons rations fluctuate widely turn by turn to create a smooth 0 to 100 to 100% visualization for agency admin. The server must the raw ratio draw a sigma the functions sigma of r equals r divided by 1 plus o2 to the power of negative k times r minus 0.5 with 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 the simplest with simplest functions key values sleepness functions of 8. This transforms noisy data into a stable elegant curve on the admin analytics dashboard while saving up to 70% in token cost. Let's jump to algorithm P, domain guardrail and intent classification. In a real-world voice receptionist called mate ask completely off-topic questions like what is Bitcoin or can you write me Python code? Based on those random queries to OpenAI Born's API tokens and arrange the professional receptionist persona. To prevent this, we built a customer lightweight NLP classifier that evaluates user intent on the fly before calling API. Let's look at the pipeline stages. First, speech to text engine. After broadest typos, for example, transcribing to to take as to take We use a Levenstein edit distance matrix powered by dynamic programming. If the edit distance is less than or equal to 2, it still safely matches the target domain vocabulary. Next, we vectorize the input text using TF-IDF, calculating form frequently weighted by inverse document frequency across our domain corpus. Within compute the cousin similarity, measuring the cousin of the angel between the user's sparse IETF IDF vector and our in-domain versus out of scope vocabulary function vector, sorry, vectors. And we combine those into a hybrid score 60% TF-IDF white plus 40% busy Levenstein weight. Finally, we map both in domain and out of scope score through two class softmax functions. This converts raw similarity score into a clear 0 to 1% confidence metric. If the confidence drops below the threshold, the system blocks the request locally with zero OpenAI cost. beyond the business logic, we engine algorithm the conversation audio engine paired with an issue detection safe word to make voice responses feel natural. The engine applies real-time tone and the pitch modulations while dynamically computing an incremental running latency incremental running average formula uh, to solve the common voice AI trap where the microphone picks up the speaker of an audio. We built a two-stage ETO detector using Jacquard word overload over over overlap combined with n-gram substring matching if user input shares over 65% overlap with the recent AI speech is it's discarded, essentially preventing infinity loops for backend for backend resilience and their lead. We implemented two critical support structured first an LRU cache in file server algorithm LRU cache.js component a hash map with a double linked list. It keeps the five most active profiles in a memory with the strict 0 and 1, uh, or 1 operations, eliminating database disk trashing. Second, consistent uh, consistent hash ring for future database sharding using a 22-bit FNV and 1A hash algorithm and 128 virtual nodes per shard. In common clinic IDs map across distributed database shards with minimal redistributions when scaling out. So, why is vocal engineered not to crash under thousands of concurrent calls? Because every single request flows through seven defensive layers. One, HTTP rate limits block abusive IP floats with the 429 too many requests. Second, per clinic token buckets cap sudden sudden traffic bursts. Three, binary heap queries event emergency medical calls first. Four, domain guardrails drop off of looping spam locally before reaching OpenAI. Five, memory compressions bounce RAM footprint to 4 turns. Six, multi-tenant isolations ensures clinic as traffic never degrades clinic B and seven and if If OpenAI goes down completely, our local deterministic state machine handles booking end to end without failing. Thanks for watching. My name is Khalil Elkhattab. This project is completely open source. Check out the code on GitHub in the link below and feel free to connect with me on LinkedIn. See you next time.